In this video, we're going to put the quotient rule to practical use. In a previous video, we proved the quotient rule. Now we'll just do a few examples. So let's start with this one. Suppose we want to find the derivative of that expression. Well, we're just going to say that that derivative is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Now, a strange little mnemonic device is the following. If you think of the, if you just for a moment call the denominator low, call the numerator high, and then when you determine the derivative of something, call it d. So d low means derivative of the denominator, and d high means derivative of the numerator. Then you can remember this as low d high minus high d low over low low. Now, if that helps you, feel free to use it. If you'd prefer to just remember the formula, well, then you're more mature than me and good for you. But if you wanted to simplify that, you could make that 6x squared minus 8x up top all over x squared plus 5 quantity squared. And it isn't always a requirement that you need to simplify, but sometimes it is not too difficult to do that. And so when that happens, sometimes it's nice just to do a quick simplification. And doing that quick simplification, we get negative 3x squared plus 8x plus 15 all over x squared plus 5 quantity squared. Okay, here's another one. Let's determine the equation of the tangent line of this curve at x equals 0. Well, we're going to need to know a point and a slope. So at x equals 0, we know that y will equal 2 times 0 over 0 squared plus 1, which is 0 over 1, which is 0. So we know that the point in question will be 0, 0. Let's determine the slope. Well, the derivative will be low d high minus high d low all over low low. Okay, so that is 2x squared plus 2 minus 4x squared all over x squared plus 1 quantity squared. And it doesn't take long to simplify that, so we'll just call it negative 2x squared plus 2 all over x squared plus 1 quantity squared. Now, at an x value of 0, we see that y prime will be negative 2 times 0 squared plus 2 all over 0 squared plus 1 quantity squared. That's going to be 2 over 1 squared, which is 2. So what we have is the equation of the line will be y equals mx plus b. Since the slope is 2, we can say it's y equals 2x plus b. We'll temporarily sub in an x value and y value of 0, since that's a point on the line. So 0 equals 2 times 0 plus b, which implies that b equals 0. And so y equals 2x plus b just becomes y equals 2x plus 0. And we can say, therefore, the tangent line is the line y equals 2x. Okay. Next question here. Let's determine the coordinates of each point on this graph where the tangent is horizontal. Well, there's two ways we can do this question. The first way we'll do is the quotient rule. So right away we'll say that y is equal to 2x plus 8 over x to the 1/2. Now we will determine y prime. So y prime is low d high minus high d low over low low. So that's going to be 2x to the 1/2 minus, now 1/2 x to the negative half times 2x becomes x to the 1/2. I'll put a bracket around this. And then 1/2 x to the negative 1/2 times 8 becomes 4x to the negative 1/2. X to the 1/2 quantity squared, we can multiply those and get x to the 1, so it's just x. We can distribute this negative sign here into the bracket, and when we do that, we get 2x to the 1/2 minus x to the 1/2 minus 4x to the negative 1/2 all over x, and that equals x to the 1/2 minus 4x to the negative 1/2 all over x. Now, we want to know the coordinates of the points where the tangent is horizontal. So that means y prime is going to equal 0. So that means x to the 1/2 minus 4x to the negative 1/2 over x will equal 0. Multiplying both sides by x, we get x to the 1/2 minus 4x to the negative 1/2 equals 0. I'm going to multiply both sides by x to the 1/2. If I multiply the left-hand side by x to the 1/2, and I multiply the right-hand side by x to the 1/2, the left-hand side becomes x to the 1, or just x, minus 4x to the 0, or just 4. The right-hand side is an expression times 0, which is just 0. So x minus 4 is 0, which means x equals 4. Now, if x equals 4, I simply take that value and plug it in for y. Y will be 2 times 4 plus 8 over the square root of 4. That becomes 16 over 2, which is 8. So the point in question, there's only one such point, and it's the point 4, 8. That's one way of doing it. But I'll be honest with you, there's another way, and it's a little quicker than using the quotient rule in this case. There's nothing wrong with the quotient rule here, it works, but we can also use our noggins a little bit. When there's only one term in the denominator and it contains an x, then a lot of times it's a little quicker to do what I'm about to do. So whenever there's a fraction with only one term in the denominator, you can divide each term in the numerator by that term, then use the power rule, and it might lessen your work. So what that means is, when you see this expression, if I gave you 2x over root x plus 8 over root x, if I gave you that expression, you'd instinctively say to me, well, sir, you can just call that 2x plus 8 over root x. And I'd say, of course, you're right. Well, I'm asking you now to go backwards. Split it apart. So think of our expression f of x as really being 2x over root x plus 8 over root x. If you think of it that way, then what you have is 2x over x to the 1/2 plus 8 over x to the 1/2. Now, in this case here, we're dividing x by x to the 1/2. We can subtract those exponents. X to the 1 divided by x to the 1/2 becomes x to the exponent 1 minus a half, which is x to the 1/2. So that becomes 2x to the 1/2. And this 8 over x to the 1/2 becomes 8x to the exponent negative 1/2. So that's what f of x equals. It equals this expression here. Once you have f of x equaling that, you can use the power rule, and your work is really cut down. So just to clarify, we've simplified things to f of x equaling 2x to the 1/2 plus 8x to the negative 1/2. We're now going to determine the derivative. So 1/2 times 2 is 1, x, and then we have negative a half. Negative a half times 8 is negative 4, x to the negative 3 halves. I'm going to set that left side equal to 0, and the right side will stay the same. Now I'd like to solve that, and one way I can do it is by multiplying both sides of this equation by x to the 3/2. If I do that, x to the 3/2 times 0 is simply 0. X to the 3/2 times x to the negative 1/2 is x to the 1. X to the 3/2 times 4x to the negative 3/2 becomes 4x to the 0, which is 4. So I just get 0 equaling x minus 4, and x equals 4. And then just like we did the last time, we then have to sub it into this expression to figure out what y equals. So y would be 2 times 4 plus 8 over the square root of 4, and that ultimately equals 16 over 2, which is 8, meaning the point with the horizontal tangent is the point 4, 8.